Okay, hello everyone in a new video. So we have reached part 3 of chapter 3, which is the chapter of velocity for grade 8 students. Now in this one we are going to solve some exercises as a direct application on what you have explained previously. Then extra exercise number 1, determine in the SI in each of the following cases the missing quantity. So let me start by number 1. We have that the distance d is equal to 100 meters and delta t. So notice that the distance is already expressed in the SI and the duration delta t is equal to 20 seconds already expressed in the SI. So now before referring to the missing quantity, notice that if we have the distance and the duration, we can calculate the average speed. So we are interested in determining the average speed. So always we start by writing the formula that relates Vm, d and delta t, which is given by Vm is equal to d divided by delta t. In this case, no need to construct a triangle for this formula because this is the quantity that we want to calculate. Now the value of d is given by 100, the value of delta t is given by 20. Plugging this fraction on the calculator, then the value of Vm is given by 5. Since both d and delta t are expressed in the SI, so the unit of Vm will be in the SI, which is meters per second. Then Vm is equal to 5 meters per second. So this is it for number 1. Now in number 2 we have that Vm is equal to 30 meters per second. As for the distance d, it's equal to 10 meters. So notice that the average speed is already expressed in the SI. Now the distance is equal to 10 meters. Looking at these quantities, one can calculate the duration. Then indeed they are asking me about the duration delta t. We know that delta t, Vm and d are related via the following formula. Knowing that we are interested in determining the value of delta t, so constructing the triangle of this formula, here because we have divide, then Vm will be at the bottom, d at the top, delta t here. Putting our hand over delta t, then delta t eventually is given by d divided by Vm. The value of d is given by 10 and the value of Vm is given by 30. Plugging this fraction on the calculator, then the value of delta t is given by 0.33. Since both d and Vm are expressed in the SI, so the value of delta t will be in the SI, which is seconds. Then in this case, delta t is equal to 0.33 seconds. Now as for number 3, they are telling me that Vm is equal to 25 meters per second already expressed in the SI, and the value of delta t is given by 10 seconds. We are interested in determining d. Knowing that Vm, d and delta t are related via the following formula, that Vm is equal to d divided by delta t, we are interested in determining d. Constructing the triangle of this formula, here because we have divide, then Vm will be at the bottom, d at the top, delta t here. Putting our hand over d, then as you can see that d is given by Vm multiplied by delta t. Now the value of Vm is given by 25. The value of delta t is given by 10. Plugging this on the calculator, then the value of d is given by 250. Since both these are expressed in the SI, so the value of d will be in the SI, which is meters. Then the distance d is equal to 250 meters. Now as for part 4, they are telling me that the distance d is equal to 3 kilometers. Notice that kilometers is not a unit of distance. In order to convert from kilometers to meters, we multiply by 1000. Then 3 multiplied by 1000, this is equal to 3000 meters. And the duration delta t is equal to 15 seconds already in the SI. We are interested in determining the distance d, We are in this part 4, so let me change this and make it VM. Then we are interested in determining Vm, which is given by d divided by delta t. Since we are interested in determining Vm, no need to construct a triangle for this formula. 3000 divided by 15, plugging this fraction on the calculator. Then the value of Vm is given by 200. Since everything is expressed in the SI, so the value of Vm will be in the SI, which is meters per second. Then Vm is equal to 200 meters per second. Now in part 5, d is equal to 30,000 centimeters. Knowing that centimeters is not the SI unit of distance, in order to convert from centimeters to meters, we divide by 100. Then 30,000 divided by 100. So this is given by 300 meters. And in this case, delta t is equal to 5 minutes. Knowing that also minute is not the SI unit of time, in order to convert from minutes to seconds, we multiply by 60. Then 5 multiplied by 60, this is given by 300 seconds. Now in this case, we are interested in determining Vm, which is equal to d divided by delta t. No need to construct a triangle for this formula, because this is the quantity that we want to calculate. Then 300 divided by 300, this is equal to 1. Since everything is expressed in the SI, so the value of Vm will be expressed in the SI, which is meters per second. Then Vm is equal to 1 meters per second. Now finally part 6. They are telling me that Vm is equal to 72 kilometers per hour. Knowing that kilometers per hour is not the SI unit of speed, in order to convert from kilometers per hour to meter per second, we simply divide by 3.6. Then 72 divided by 3.6, plugging this on the calculator, then it's given by 20 meters per second. As for the duration delta t, which is equal to 3 hours, knowing that hours is not the SI unit of time, in order to convert from hours into seconds, we multiply by 3600. Then 3 multiplied by 3600, so this is equal to 10,800 seconds. Now we are interested in determining d, so let's write the relation that relates Vm, delta t, and d, which is given by Vm is equal to d divided by delta t. We are interested in determining d. Constructing the triangle of this formula here, because we have divide and Vm will be at the bottom, d at the top, delta t here. Putting our hand over d, then d eventually is given by Vm multiplied by delta t. The value of Vm in the SI is given by 20. The value of delta t in the SI is given by 10,800. Plugging this on the calculator, then the value of d is given by 216,000. Since all quantities in physics must have unit, and this number must have unit, since Vm, delta t are expressed in the SI, so the value of d will be in the SI, which is meters. Then the distance d covered in this case is given by 216,000 meters. Now let's move to the next exercise, which is exercise number 2. They are telling me compare in each of the following cases the two speeds v1 and v2. So in this case, these speeds may represent the average speed or the instantaneous speed. Now by compare, it means that we need to say whether one is greater, equal, or less than the other. So we have that v1 is equal to 30 meters per second. First of all, before we compare, in physics, whenever we need to compare two numbers, we need to make sure that both numbers have the same unit. So notice that in this case, v1 is being expressed in meters per second and v2 is being expressed in meters per second. So directly we can compare between v1 and v2. So notice that in this case the value of V2 is greater than V1. So this is the comparison between V2 and V1. Now as for number 2, V1 is given by kilometers per hour and V2 is given by meter per second. So we can directly notice that they are expressed in different units. So in order to compare them, we need to convert. For example, let's convert kilometers per hour to meter per second, both of them in the SI. So V1, which is given by 50 kilometers per hour. Then in order to convert from kilometers per hour to meter per second, we simply divide by 3.6. Then 50 divided by 3.6. Then it's given by 13.89 meters per second. Then in this case, V1 is equal to 13.89 meters per second, whereas the value of V2 is given by 73.5 meters per second. And in this case, we have V2 is greater than V1 because 73.5 is greater than 13.89. So I repeat, whenever we need to compare two quantities in physics, they must have the same unit. Now in number 3, V1 is expressed in meters per second and V2 is expressed in kilometers per hour. Then let's convert kilometers per hour to meter per second in order to compare between V1 and V2. V1 is equal to 30 meters per second, whereas V2 is equal to 20 kilometers per hour. In order to convert from kilometers per hour to meter per second, we divide by 3.6. So 20 divided by 3.6, this is equal to 5.56 meters per second. Then in this case, V1 is equal to 30 meters per second and V2 is equal to 5.56 meters per second. Then in this case, 30 is greater than 5.56, so V1 is greater than V2. Now in number 4, so notice that in this case, both of them are expressed in kilometers per hour, although it's not the SI, but we can compare directly. So V1 is equal to 120 kilometers per hour, and V2 is equal to 80 kilometers per hour. So directly we can say V1 is greater than V2 because 120 is greater than 80. So I repeat, whenever they ask us about the comparison, we need to say greater, equal, or less than. Now let's move to exercise number 3, extra exercise number 3. They are telling me a swimming pool is 50 meters long. So what does 50 meter represent? Always physical quantities are referred. In order to determine what does this physical quantity represent, we refer to its unit. So this holds the unit m, which stands for meters, and we know that the meters is the unit of distance. So we have that the distance d is equal to 50 meters, already expressed in the SI. And they are telling us a swimmer covers it in 50 seconds. So because seconds is the SI unit of time, so this quantity represents time. Now what does it represent? Does it represent an instant time t1 or t2 or the duration delta t? Because they gave us one value of time, so it represents the duration delta t. However, if they gave us two instant times representing two different events, then they will represent the instant times. So in this case, the duration delta t is given by 50 seconds. And they are telling me to calculate the average speed, which is denoted by Vm. So we always start by writing the formula, which is given by d divided by delta t. So usually this we give it half a mark. The value of d is given by 50. The value of delta t is given by 50, which is equal to 1. Since both d and delta t are expressed in the SI, so the value of Vm will be in the SI, which is meters per second. So Vm is equal to 1 meter per second. Now, as for extra exercise number 4, they are telling us that sound travels at 330 meters per second in air. So the speed of sound is equal to 330 meters per second. They are telling me to express this in kilometers per hour, so simply we need to convert from meter per second to kilometers per hour, and this is done by multiplying by 3.6. Then 330 multiplied by 3.6, plugging this on the calculator. Then the speed of sound in air is given by 1188 kilometers per hour. So V of sound given by 1188 kilometers per hour. So as you can see that whenever we are converting the speed from meters per second to kilometers per hour, we expect that the value will get larger. Now as for extra exercise number 5, they are telling me a snail takes 16 minutes 40 seconds. So this quantity here represents time. But what does it represent? Does it represent instant time t or duration delta t? So it represents duration delta t because simply this is one value of time. If they gave us two values of time, then they will represent t1 and t2. So in this case, delta t is equal to 16 minutes and 40 seconds. Notice that this duration is not expressed in the SI. In order to convert it to seconds, we need to multiply 16 by 60 and add to it the 40 seconds. Now plugging this expression on the calculator, then it's given by 1000 seconds. So it takes the duration delta t 1000 seconds to cover a distance of 1 meter. So the distance already is in the SI. Now they are telling me, okay, before referring to the question, if we consider delta t and d, knowing delta t and d, which physical quantity we can calculate? We can calculate the average speed Vm because it's given by d divided by delta t. Then indeed, they are telling me calculate in meter per second the average speed of the snail. So Vm is equal to d divided by delta t. Now, before we calculate this value, recall that in the beginning of the part 2 of chapter 3, we have defined the speed as a measure of how fast an object is moving with respect to time. So if we are talking about the speed of a snail, the average speed, we expect that this number will be very small because we know that a snail moves at a very low speed. Now let's calculate it. The value of d is given by 1, the value of delta t is given by 1000. Since both d and delta t are expressed in the SI, so the value of Vm will be in the SI, which is 0.001 meter per second. And as you can see, this is a very small number, which reflects that the snail has a very low speed, which indicates, so what does the speed represent? How fast an object is moving with respect to time. Now, as for extra exercise number 6, they are telling me the average velocity of a tennis ball is measured during serving and foul to be Vm is equal to 216 kilometers per hour. Notice that kilometers per hour is not the SI unit of time. In order to convert from kilometers per hour to meter per second, we divide by 3.6. Then 216 divided by 3.6, this is equal to 60 meters per second. Calculate the time elapsed between hitting the ball and meeting the ground. If the distance covered by the ball during that interval is 20 meters, so d is equal to 20 meters. Now, knowing Vm and knowing d, we can calculate the duration delta t. In fact, they are telling me the time elapsed between hitting the ball, so this is the instant t1 when we hit the ball, and this is the instant t2. And by the time elapsed means the difference between t1 and t2, which is given by delta t. So we are interested in determining delta t. So as usual, we start by writing the formula, which is given by Vm is equal to d divided by delta t. We are interested in determining delta t. So constructing the triangle of this formula, here because we have divide and Vm will be at the bottom, d at the top, delta t here. Putting our hand over delta t, then delta t is given by d divided by Vm. The value of d in the SI is given by 20. The value of Vm in the SI is given by 60. Plugging this on the calculator, then the value of delta t is given by 0.33. Since dm and vm are expressed in the SI, so the value of delta t will be in the SI, which is seconds. Then delta t is equal to 0.33 seconds. And now let's move to the next exercise. And this exercise from the textbook, page 63, number 8. Curiosity arrives to Mars. So here in the following document they are showing us NASA's Curiosity spaceship left for Mars on November 26, 2011. It landed on the red planet on August 6, 2012. After traveling a distance d, so we have the distance d to be an unknown, in 255 days. So what does this quantity represent? We know that days is a measure of time. Okay, so this represents time. What does it represent? Does it represent instant time or duration? Since here we have only one value of time, so it represents the duration delta t, which is equal to 255 days. Now the average speed of the spaceship is approximately 91,500 kilometers per hour. Let me write it here. In 8.1 they are telling me what's the duration of the spaceship flights an hour. So we need to convert this duration into hours because they are specifying the unit. If they didn't specify, we should calculate the duration delta t in seconds. So knowing that each day includes 24 hours, then 255 multiplied by 24, plugging this on the calculator, then the number of hours for this flight is given by 6,120 hours. So the duration delta t is given by 6,120 hours. Now in 8.2 we are asked to calculate the distance d traveled by the spaceship in kilometers. Knowing Vm, knowing delta t, we can calculate d using the formula Vm is equal to d divided by delta t. Constructing the triangle of this formula here, because we have divide, then Vm will be at the top, at the bottom, d here, delta t here. Putting our hand over d, then d is given by Vm multiplied by delta t. So in order to calculate d in kilometers, first we will calculate d in meters, which is the SI, then we will convert it to kilometers. So notice that here the speed is given by kilometers per hour, that's converted to the SI, which is meters per second. Then dividing it by 3.6, it is given by 25,416.67 meters per second. As for the duration delta t, which is equal to 6,120 hours, in order to convert from hours into seconds, we multiply by 3,600, then 6,120 times 3,600, this is equal to seconds. So why we have done so? We have determined Vm in the SI, and we have determined delta t in the SI. So now the value of d will be in the SI, which is meters. After we have determined d in meters, we will convert it back to kilometers. Okay. So the value of Vm is given by 25,416.67 multiplied by this value. Now plugging this on the calculator, then it's given by 5.6 times 10 to the power 11, because Vm and delta T are expressed in the SI, so the unit of D will be in the SI, which is meters. So D is equal to 5.6 times 10 to the power 11 meters. But notice that we are asked to calculate the distance D in kilometers and not in meters. Now D, which is equal to 5.6 times 10 to the power 11 meters, in order to convert it to kilometers, we simply divide by 1000. Then dividing it by 1000, then it's given by 5.6 times 10 to the power 8 kilometers. Okay, then D is equal to 5.6 times 10 to the power 8. Sorry. So this is it for exercise number 8, and so that's it for me in this video, guys. In the next part we'll complete solving exercise on this chapter and complete the explanation as well.